Everything from the music on your car radio to the Wi-Fi that's powering this very moment, it all runs on invisible signals. But have you ever stopped to think about how a piece of information, like a voice or a picture, actually travels through thin air? Well, the secret is a really clever bit of engineering called signal modulation. And once you get it, you'll see our whole wireless world a little differently. I mean, it seems like it should be pretty simple, right? Your voice creates a sound wave, which is a signal. So why can't we just, crank up the volume and send it out? Turns out there's a huge, and I mean huge, physical roadblock that engineers had to figure out a way around. And it all comes down to size. That's the problem right there. Antenna size. The lower the frequency of a signal, the bigger the antenna has to be to send it out efficiently. And for the low frequencies of human speech, well, we need an antenna that's literally hundreds of kilometers long. Just imagine that. So yeah, not exactly practical. Engineers needed a way to package our information for a much better delivery system. And this is it. This is the brilliant solution. It's called modulation. Instead of trying to shout our low-frequency message into the void, we use it to change or modulate a completely different signal, a really high-frequency one that can be transmitted super easily with a normal-sized antenna. Okay, this is the best way to think about it. Your voice, your data, whatever it is, that's the package you need to send. The high-frequency wave, that's the delivery truck. It's built for speed and long distances. So modulation is just the process of loading the package onto the truck. Simple as that.
So how does this actually work in practice? Let's take a look under the hood at the original method, amplitude modulation. You know it as AM radio. It's the simplest example, and it's really the foundation for so much that came after.
All right, let's look at the three key ingredients here. Up top, you've got our delivery truck. That's the high-frequency carrier wave just humming along at a constant rate. In the middle, that's our package, the low-frequency information we want to send. And then, down at the bottom, you see the final product, the combined AM signal. The package is officially on the truck, and it's ready to go. So how do we get that final shape? Well, this is the cool part. The height, or the amplitude of our information signal, literally dictates the amplitude of the carrier wave. See how the outline of that final signal, what engineers call the envelope, is a perfect copy of our original message? It's like the truck is now wearing the shape of the package. Now, you have to be really careful about how you do this. There's something called the modulation index, which is just a fancy way of saying how much we're changing the carrier. The golden rule is this. Your information package can't be bigger than the truck. If the peak of your information signal is higher than the carrier's, you get what's called overmodulation, and it just sounds like a distorted, garbled mess. Now this is what you want to see. This is the sweet spot, a signal with 100% modulation. The highest point of the information signal is exactly the same height as the carrier signal. This is absolutely ideal, because you're sending the strongest possible message without a shred of distortion. Okay, great. So we solved the giant antenna problem, we've put our package on the truck, we've sent it off, we're done, right? Well, not so fast. It turns out this whole AM radio thing, as clever as it is hiding a really surprising and frankly massive inefficiency. So let me ask you this. Where is the actual information in that final signal? It's kind of a trick question. You'd think it's in that big, powerful carrier wave, right? I mean, that's the main frequency we're sending out. But believe it or not, that's not where the package is actually stored. To find the information, you have to look at the signal in a totally different way, by looking at its frequencies. See, the process of modulation doesn't just mix waves together, it actually creates brand new frequencies. Your original carrier is still there, right in the middle, but your information, your package, has been copied into two new spots on either side of it. These are called sidebands, and that's where the message actually is. And here it is. This is the big, shocking reveal. When you look at where all the broadcast power is going, it's kind of nuts. A full 2/3 of the energy is spent just transmitting the carrier wave, the delivery truck. Only 1/3 of the power is actually used for the sidebands, the part with all the information. We're spending most of our power just to send an empty truck. This quote just nails it. The carrier does its job to get the signal ready for the trip, but after that, it's useless. It contains none of the actual message. It is literally an empty truck that's eating up 2/3 of the gas. Talk about a massive waste of energy. So once engineers realized this staggering inefficiency,
They did what they always do. They found a smarter way to work. They figured out how to send the package without having to send the entire truck along for the ride.
The logic here is just beautiful in its simplicity. If the carrier has no information, why are we broadcasting it? Let's get rid of it. And since the two sidebands are just mirror images of each other, they carry the exact same information. So why send both? This thinking led to a much more advanced technique. And this chart just says it all. Look at the difference. Old school AM sends that power-hungry carrier plus 2 redundant sidebands, but single sideband, or SSB, is so much smarter. It transmits only 1 sideband. That's it. Suddenly, 100% of the power is focused on the actual message, and it takes up only half the space on the airwaves.
I mean, the benefits here are just enormous. You're saving a ton of power, which means smaller, more efficient gear. You're using half the radio spectrum, which is like turning a 2-lane highway into a 4-lane one. It frees up so much space. And because the signal is so concentrated, it's clearer, it's less noisy, and it holds up way better over long distances. It's a win-win-win.
This whole journey from a simple idea to a super efficient solution is really the story of engineering, isn't it? It just goes to show you that even in this invisible world of signals, there's always a smarter, more elegant way to deliver the message. It really makes you wonder, what's the next empty truck that we're going to learn to leave behind?